When you hear the term simple machines, things like levers, wheels, pulleys, you're probably thinking about a physics class, right? But what if I told you that the most sophisticated machine on the planet is you? And it's absolutely packed with them. In this explainer, we're going to pull back the curtain on one of the coolest, the hidden pulley systems that make all of our movement possible. Okay, so let's start with a little puzzle. Take a look at these two pictures. On one side, you've got a standard weight machine from a gym. On the other, a diagram of a human knee. Now, at first glance, what could these two possibly have in common? They look totally different. But trust me, they share a secret, a really elegant engineering principle that's fundamental to how they both work. Let's break it down. So, to really get that connection, we have to start with the basics. And that means looking at the first and most common type of pulley, the kind you see all over the gym. Yep, we're talking about the fixed pulley. A fixed pulley is, well, it's pretty much exactly what it sounds like. See how the wheel part is bolted to that support? It doesn't move. It's fixed in place. A rope just goes over it, you pull down on one end, and voila, the weight on the other end goes up. It's a super simple concept, but it's incredibly useful. Now, here's the key thing that a lot of people miss. A fixed pulley doesn't actually make you stronger or make the weight feel lighter. Its real superpower is just changing the direction of the force. I mean, it's way more convenient to pull down to lift something up, right? That simple change of direction is the whole point, and it turns out to be a total game changer. This brings us to a concept called mechanical advantage, or MA for short. For a fixed pulley, the MA is just 1. All that means is the force you put in is the exact same force you get out. If you want to lift a 10-pound weight, you've got to pull with 10 pounds of force. It's a 1-to-1 deal. So again, no extra strength, just that super handy change in direction. But what if you do want to make lifting something easier? What if you want a little help, a little boost in strength? Well, for that, you need a different kind of tool. And that brings us to our second type, the movable pulley. Right away, you can see this setup is completely different. Check it out. One end of the rope is anchored up top, but the pulley itself, it's attached directly to the weight. So when you pull on the rope, the whole pulley moves right along with the load. It's not fixed at all. Now, this system comes with a really interesting trade-off. Because the weight is now being supported by 2 strands of rope, the effort you need to put in is basically cut in half. You get this awesome gain in force. The catch? You have to pull the rope twice as far to lift the weight the same height. It's a trade-off. Less effort in exchange for more distance. And this is where the magic really happens. Remember that mechanical advantage? For this setup, the MA is 2. So that 10-pound weight from before, now it feels like you're only lifting 5 pounds. You have effectively doubled your strength just by changing how the ropes and pulleys are arranged. How cool is that? Okay, so we've got 2 main pulley designs. One changes direction, and the other multiplies your force. Now get ready for this, because this is the mind-blowing part. Evolution, the ultimate engineer, has already built one of these elegant systems directly into your body. That's right, forget about all that fancy gym equipment. The most incredible, most sophisticated machines you will ever use are the ones you were born with. So what exactly is an anatomical pulley? Well, it can be a bone, a piece of cartilage, or even a ligament, and its main job is to change the direction of a muscle's pull. Change the direction. Does that sound familiar? It should. It's the exact same function as a fixed pulley. And a star of the show here is your patella, your kneecap. Think about what happens when you straighten your leg. Your big quadriceps muscle contracts, and it pulls on its tendon. Your kneecap sits right there in the middle and acts like a perfect little fixed pulley. It lifts the tendon slightly away from the joint, improving the angle of pull and giving your muscle way better leverage. It makes the whole movement much more powerful and efficient. And believe me, the knee is just the beginning. Our bodies are absolutely packed with these clever biomechanical solutions, often hiding in places you would never ever expect. Go ahead, take a look at your own hand and make a fist. As you do that, there are tiny little fibrous loops inside your fingers acting as pulleys. Their job is to hold your flexor tendons down, keeping them snug against the bone. Without those little pulleys, the tendons would pop up like a bowstring every time you tried to grip something, and your grip strength would be almost non-existent. Get this, there's even a pulley system in your neck. A little fibrous loop redirects a muscle called the digastric, and this clever little change of direction is part of what allows you to do something as simple as opening your jaw. And sometimes the pulley isn't a ligament, but it's a piece of bone itself. Deep inside your hip, a muscle literally makes a sharp 90-degree turn around a bony groove. That groove acts as a perfect pulley, redirecting the muscle's force to help you rotate your thigh outward. It's just genius design.
So when you lay it all out like this, a clear pattern emerges. Our bodies exclusively use fixed pulleys, things like the patella, those fibrous loops, and the bony grooves. Their job is to alter the direction of force, so they have a mechanical advantage of one. But what about the movable pulley, the force multiplier? Well, we don't have any of those in our anatomy, but we have found a clever way to use them clinically.
And that's where this application comes into play. In physical therapy, movable pulleys are used in these amazing suspension systems. By supporting a limb, or as you see here, the entire trunk, the pulley system does what it does best. It cuts the effort needed to move. A 6-kilogram trunk can be moved with just 3 kilograms of effort. This is huge for allowing patients to exercise and rebuild strength much more safely. Ultimately, the takeaway here isn't just that our bodies have pulleys. It's that our bodies are a masterclass in applied physics, using simple, elegant solutions to create the complex miracle of human movement. It really makes you wonder, doesn't it? What other engineering marvels are hiding right now, in plain sight, inside you?